every month. I've got the website, the Slack, which is through the KnoxDevs.com, Meetup, Twitter, GitHub, and email and all that. So the best way to keep up to date with upcoming events is through the Meetup. I've had some questions about doing like an email newsletter thing. I don't know if people are still interested in that or not, but we may do that in case you don't like to use Meetup or Twitter. And just wanted to say, I think next month we'll probably just meet across the street. We don't have a presentation or anything, but just sort of like a Christmas social event or something. You don't have to be 21 to go there. You just have to be 21 to drink. So you can still hang out, and they usually have a food truck out there too. So if you want to grab dinner, and I think we're going to do it with the data science group, which Alex helps organize too. So if you can tell those people to quit using R and they should be using Python. I had to say it. So that'll be next month. And then I don't think we'll meet in January since it's so close to New Year's and all that. So we'll probably start back again in February. So if you know of anyone that wants to do a demo or presentation for next year, just let us know. Or if you want to hear a particular topic, let us know too. It's about scheduling. And then one last thing is so PyTennessee is coming up in February. It's February 10th through the 11th in Nashville. This is sort of just a regional Python conference. If you're interested in going, we did get some discounts for it. That I think it was up to 5. It should be in the Slack channel, and it was $10 off or something. It's already pretty cheap. It's big tickets or early bird tickets are like $60 for the entire thing. So try to go to that if you can, and submit some talks and tell everyone you're from Knoxville, Tennessee. So you might have any questions about anything, or
if it's the in December, we're still gonna do the.
Yeah, we're ready.
Okay.
Let's wear some warm clothes. We'll still hang out outside.
I'm rooting for snow, but
It'll probably be like 70.
Yeah,
Anyway, I'll turn it over to Josh. He's going to talk about some testing and Python.
So my name is Josh Kelly. I work as a software developer at Windrock. We make diagnostic equipment for oil and gas industry. So a lot of my day job is C++ programming, but I'll use Python any chance I get. You know, for automations and scripting at Windrock and for various side projects. And the reason I'm going into all of that is because I do not consider myself to be an expert on automated testing in general or on Pytest in particular, but this is some stuff I've been playing with for the last month or two, and some stuff that I found helpful. With that said, you know, I'm open to, I welcome any discussion and feedback, if, you know, for your own perspective or your own experience. You know, speak up and let me know. Feedback helps me get better as a presenter and as a developer, so I appreciate it. Tonight's talk is automated testing with Pytest. That didn't work well enough. This is my first time using this laptop to present, so I apologize for any technical hiccups.
Thank you.
All right. So tonight's talk is automated testing with Pytest, or alternate title for the talk, making Pytest your Batman. And we'll explain a little bit as we get further into it. So the first obvious question is, what is automated testing? And if you go online, you can find or shop at on Amazon or whatever, you can find countless books and articles and blog posts and discussions on how all of this works. But really, the basics are really pretty simple. And it's kind of an extension on what we do already as developers. Anytime we're doing software development, first thing we do is write some code. For example, suppose we need to calculate a Fibonacci number. The Fibonacci numbers, each Fibonacci number is equal to the sum of the previous two numbers. So it starts with 0 and then 0 and 1. 0 and 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 and 5 is 8, and so on. And so if we need to calculate this for whatever reason, we'll bang out some code to do this. I would not suggest writing code like this for production because this is going to be horribly slow the way it recursively recalculates a whole bunch of work. But for an initial version or getting proof of concept, it works. And then after you write your code, you'll test it. So depending on your type of program, maybe you'll run it from the command line, maybe you'll fire up your web browser to look at your Flask or Django app, or maybe you'll load up IPython and play with it that way. So for this example, we'll go ahead and run IPython. That is probably not legible. I apologize, I don't know myself for a while now. I'll have to skip the live demo. So if you've never used IPython, it's a interactive Python shell. And basically you can type code in IPython and it'll execute it live, just one line at a time. So we'll, we wrote our fib function, we'll save it as fib.py, and we'll fire up IPython, go ahead and import it, and then we can just start typing out commands and inspecting the results as we go. And so first Fibonacci number is 1, the third Fibonacci number is 2, fourth Fibonacci number is 3. And so at this point, I'm pretty confident that my function is working like it should. And like I said, so far we've done pretty much what we do just normally as we're writing a code and manually testing it. So automated testing is just going one step further. We'll go ahead and actually write some tests to verify that the results are what we expect. And here I'm just using Python's built-in assert statement. So it'll go ahead and evaluate this. And if it's false, then Python will raise an assertion error. And if it's true, it'll go ahead and continue. Then once we've written a few assertions like this, IPython lets you save the session, so you can save the commands you've been typing. And you go ahead and put in the line numbers here. It helpfully puts the line numbers next to each prompt. So you can see I skipped the places where I was just playing around and just saved the test part. And once I've done that, I now have an automated test. And so anytime I want to, I can run test_fib.py to verify that my code still works like I think it does, that I haven't broken it as I'm doing ongoing development or whatever. And like I said, at the very basic level, this is what automated tests look like. Typical automated test or unit test, it's a small scale automated test, is you just set up a function or a class to do this kind of thing. And they typically follow the common structure of first you arrange, where you set up your inputs and preconditions. In the case of Fibonacci, there isn't really anything to arrange, but for a more complicated unit test, you might be creating a class instance or setting some parameters or otherwise preparing some data. Then you go ahead and act. In this example, the act would be calling the Fibonacci function. And then you assert. So you take the results of your operation, for example, the results of the fib function, and verify the results to make sure that you get what you expect. So, and like I said, at the basic level, that's all it is. And then test suites like Python's built-in unit test or like Pytest offer various ways to streamline that and make it easier to work with, give you help report on your results and so on. So that's the automated testing at the basic level. Once you get more into it and try to discuss, what should automated tests look like and what's the best way to do it, this can get controversial in a hurry. If you followed any of the blogs and articles online. Part of the problem is sometimes even the terminology is different. And there's a lot of terminology that's tossed around. Of course, basic automated testing is just anything that's automated versus manual. A lot of the discussion about automated testing is actually talking about unit testing. And that's because as programmers in day-to-day development, unit testing is probably what should get most of our attention. Unit testing just means taking the smallest unit of code, whether that's a function or a class or a particular class method, and testing that by itself to make sure that it does what it's supposed to. And then a particular kind of, or school of thought, or school of development with unit testing is test-driven development, where you actually write your unit tests before you write your code. So you write a unit test, which will fail because you haven't written any code yet, and then you write the code necessary to make the test pass. If you move up a level from unit testing, you'll have integration testing or component testing, which is testing a group of related units and making sure they work together. Going up a level from there, you'll hear about system testing or end-to-end testing. For example, that might mean firing up your web application and issuing a user request and verifying that it works all the way through. And you'll hear different variations in some of these terminologies. For example, some people will distinguish between, well, integration testing is a little bit smaller than a component or vice versa. And then there's a whole other, all of these are different kinds of functional testing. In other words, making sure the program does what it says it does. And then there's a whole category of other non-functional testing, such as stress testing, security testing. And a lot of that can be automated too. You can automate stress testing your web application to make sure it doesn't fall over, but that's kind of outside of the scope of what we're talking about tonight. So, like I said, you pretty quickly get into some pretty strong opinions if you read about this stuff online. For example, Robert Martin, otherwise known as Uncle Bob, writes in Clean Code, he defines test-driven development. You may not write production code until you've written a failing unit test. You may not write more of a unit test than is sufficient to fail. And then you may not write more production code than is sufficient to pass the currently failing test. And Uncle Bob's pretty dogmatic about this. He says that test-driven development for software developers is comparable to hand washing for doctors. He strongly implies that you're not professional if you don't do it. Now, Clean Code's one of the best programming books I've read. And if you haven't read it, I'd recommend taking a look at it. But I don't think I would agree with them here. Some of that's in a lot of the development I do, interfacing with hardware or trying to make sure a plot looks right or trying to make sure a series of math operations comes out. And it's kind of hard to write a test for that ahead of time. And part of it is I'd rather, test-driven development is one way to get a good test suite, but what I care about in the end more is, do I have the kinds of automated tests that give me confidence that my code's going to keep working, regardless of how I get there? Another example you'll sometimes find online is, or in books, this is from Michael Feathers, working effectively with legacy code. He says unit tests run fast. If they don't run fast, they aren't unit tests. So he's kind of trying to pin down the definition of a unit test here. He says that 1/10 of a second is slow for a unit test. And his thinking is that a mature application will have hundreds or thousands of unit tests, and so you want them to run as fast as they can. And so he goes on, other kinds of tests often masquerade as unit tests. The test is not a unit test if it talks to a database, it communicates across a network, it touches a file system, or you have to do special things to run it. Now, this book, Working Effectively with Legacy Code, it's a really good resource on how to take old, hard-to-test applications and modernize it. And so Feathers really knows his stuff. And there's a lot of truth to his rationale that you want your automated tests to be so fast and so easy to run that there's no excuse not to run them. Because otherwise, well, you know, it's easy to get a little lazy or a little undisciplined. And so there's a lot of good points here, but at the end of the day, I'd rather have a test suite that is fast enough, even if it doesn't follow these rules, than has something that, you know, then jump through a lot of hoops to fit all of this. So my own approach to automated testing, you know, is kind of summed up in this quote from Matthew Wilson. He's a C++ developer. He says, "I'm lazy, as all good engineers are wont to be. Being lazy means you don't want to find bugs at runtime. Being lazy means you don't want to ever make the same mistake twice. Being lazy means making your compilers work as hard as possible so you don't have to. If you treat it well, you can make your compiler your right-hand man, helper, conscience, your Batman." Wilson's a C++ developer, so he talks in terms of compilers, but we can substitute computers in general for that there. You know, as software developers, we automate things for a living. We make computers do things for other people. And so I want to make my computer do my work for me too. I want it to catch my bugs and do my tests and so on. And so that's a lot of why automated testing is appealing to me. He goes on to explain that Batman's it's a term from the British Empire. It refers to a servant or orderly who's attached to a military officer. So more Samwise Gamgee than Bruce Wayne. But make Pytest your Samwise doesn't have the same ring to it. So, and the other big appeal of automated testing in my mind is you get faster feedback. And really a lot of the field of software development, you know, for years now has been how do we get faster feedback on our work? Switching from batch processing in the 1960s to interactive computing. Syntax highlighting means our editors can tell us if we have a syntax error in our code, you know, without having to leave the editor. IDEs offer code analysis. They can tell you if your parameters are wrong or you're referring to undefined variables without having to go to build or run your code. Faster feedback's a huge emphasis within agile software development. You know, they talk about getting on-site customers and answer your questions quickly and getting shorter iterations and so on. So you can find out as soon as possible if you're on the right track. Continuous integration means that every time you commit your code, you get the build server will give you feedback on how you're doing instead of having to wait for big bang integration, you know, for your once a year release or whatever. And so automated testing is another way of looking at that, you know, if we can get feedback within seconds potentially of writing our code, of hitting save, instead of having to go manually test or hand it over to QA or, you know, worse, hand it over to a customer, we're better off. So, you know, kind of with that background or sales pitch or rationale over, putting it into practice. Like I mentioned, Python ships with a unit test module, and so that provides some basic built-in support for unit testing. Here's the here's what unit test code looks like. I took the basic IPython session that I saved and cleaned it up a little bit to fit within unit test. So every test, you organize your tests into test cases, which have to inherit from this test case class. And then within each test case, you have one or more tests. Unit test provides its own assertions so that it can give a little more detail on what's going on with your tests. So we'll assert each of the expected values. And then you have here a little bit of boilerplate just to let me run the test module by itself from the command line. And all of that's, you know, pretty straightforward and it works, but Pytest offers quite a few benefits over this. It'll do its own test discovery so that it can automatically find any tests in your project and run them without you having to do extra steps. Unit test actually can do test discovery, I think, in the current versions, although I haven't had as much luck with it. Pytest, you don't have to inherit from that test case class I showed you. It has simpler assertions. We'll go into that in a little bit. It has a bunch of plugins to extend it. We'll go into that in a little bit. It has a test fixtures feature that's really cool for sharing sharing code across your tests and simplifying your test setup. And then it has just a bunch of quality of life improvements, like a nicer output, and different command line tweaks and so on. So fortunately, switching to Pytest is pretty, so if you want to switch from unit test to Pytest, again, here's what the unit test code looks like. Here's what comparable code looks like in Pytest. You can see we don't have to use a class if we don't want to. We don't have to inherit from test case. We can just use Python's built-in assert. Fortunately, switching to Pytest is pretty easy. Run pip install, run Pytest, and let it find your tests for you instead of running whatever your test suite is. And that's pretty much it. Sure. It starts with the word test. Pytest is kind of magic. And sometimes magic is good and sometimes it's less good. I would argue that for unit testing in particular, it's nice to have some magic to cut down on the boilerplate.
Right there on step 2, so you run Pytest, you run that.
You just, if you just run the Pytest by itself in your project directory, it will search for files with appropriate names and run any tests it finds. Yeah.
And the appropriate names have test.
It starts with test underscore, or it's a class that starts with the word test. Yeah.
So you can rename all your functions. Test 3 times.
Well, so and so Pytest is also, I mean, it can, if you have existing unit test code, Pytest can act as a drop-in replacement. So unit test finds tests by anything that inherits from test case. And Pytest will still work with all of that, and it'll still work with all the unit test self dot assert equal whatever. And so that's why I say it's really as simple as these 3 steps if you want to just get started with it and play around with it. There is also a unit test to Pytest package that it'll actually go through and rewrite your code for you to not use test case and to use some simpler assertions and so on. I've never tried this. Anyway.
We can start talking about it. We have a dedicated line for us to be able to do our unit test, so that's how everything's written. But I started messing around with Pytest, and it picked up every unit test, and like you said, the output is so much easier to read. It's hard-coded, it actually does the stack trace backwards through multiple layers of calls and stuff, so you can see what's calling what to get to where it actually errored out. It's nice.
Okay. Yeah, it's I mean, I've enjoyed playing with it. I've been impressed with what it can do. So we already touched on this a little bit, but how Pytest discovery works is it'll search recursively under the current directory. Any file with test underscore or underscore test in the name, any class within those files that starts with the word test, and then any functions, whether those are free, standalone functions or class methods that start with test. And all of this is customizable if you need to override it. For example, you can exclude directories, you can tell it what directory to start at, and so on. The second benefit of Pytest, which we kind of touched on, is simpler assertions. If you try to start looking at how you write assertions, how you inspect the results of your operations to make sure they are what they are supposed to be, and unit test, it gives you a whole bunch of options that you have to keep track of, whether it's equal, not equal, whether it is or isn't something, greater than, less than, equal. And the reason that unit test does all this is so that if a assertion fails, it wants to know exactly what operation you're doing so that it can give details on what it expected versus what it got. Pytest gives you one assertion to keep track of, assert. And the way that it works is actually pretty cool. And again, this is more magic. It'll actually, as it's loading the tests, it will inspect the abstract syntax tree of your test's code and rewrite the unit tests from something like this, make sure that 1 + 2 = 3 to something like this. And it does this all internally, and you don't have to understand or pay attention to it. But you can kind of tell just you get the general idea that it's took that a plus b equals 3 and it is evaluating every piece of the expression and saving each step of the way, so that if the test does fail, it can give a very detailed message about what all the different parts evaluate to. And again, having magical code is not always a good thing. It's part of the kind of the philosophy of Python, or the Zen of Python, they call it, that explicit is better than implicit. But sometimes some magic is nice, and for unit testing in particular, I like the Pytest approach of provide some magic to streamline things and cut down on the boilerplate. Third advantage of Pytest, which we mentioned, is the various plugins. If you go to the Pytest website, they maintain this Heroku site where you can find a whole bunch of different Pytest plugins that add various functionality. A couple plugins that I've found helpful. Code coverage, so you can install Pytest COV and then add the appropriate command line options, and you'll get a real nice code coverage report. So the idea of code coverage, if you're not familiar with it, is basically it'll watch the program as your tests are executing and keep track of which parts of your program have been hit by your unit tests. And so that gives you an idea of how extensive your tests are, whether or not you're testing the parts of the code that you think you are. So for example, here's a coverage report for a Django application I've been working on. You can see right now the code coverage is 67%, which isn't spectacular, certainly could be worse. And then if you want to, you can drill down to individual pages. So for example, the sign up view for this registration site. It's kind of hard to make out on this screen. All right. So within this file, any lines that are executed are green, and any lines that aren't executed are red. And so that can give me an idea of, I can see here the happy path for sending the welcome email works just fine. If an error occurs, I'm not testing that. So if I wanted to be really thorough, I'd have to go back and do that. If I scroll down further, I can see that sending an organization request isn't tested at all. So if I have to do maintenance work on that function, maybe I need to be a little more careful than usual, or maybe I want to add a test while I'm there. And just as with, we talked about some of the discussion and debate about the different schools of thought with unit testing. Well, there's some discussion with code coverage too, as to how you should interpret the results and whether you should target a particular percentage and so on. And obviously, just because a line is green in my coverage report doesn't mean that it works flawlessly. I could have forgotten to test one particular scenario, but it at least gives me some kind of measure of how good I'm doing or how extensive my tests are covering my code. Another useful plugin I found, Pytest Watch. So you install this and run PTW, and then it'll just keep running. And anytime you save your code, it'll instantly kick off and run your test suite and tell you if anything is wrong. Pytest Xtest, I haven't had a chance to try this one out yet, but it'll distribute your unit tests across multiple CPUs or multiple hosts, so you can run the test suite faster. It can run the tests repeatedly whenever files change, so similar to Pytest Watch. Can run tests on multiple environments if you want to try to wire up a couple different Python interpreters, or if you want to test Mac OS versus Linux, for example. I'll skip the live demo because with that console so small, you wouldn't be able to see it anyway. But it's another example. It's another example of a Pytest feature. You can tell it to report the 3 slowest tests, for example. You can tell it that one of your, in addition to asserting expected values, you can assert that it should raise an exception. And so, for example, the Fibonacci sequence, maybe you want to make sure that the Fibonacci program will throw an error with a negative number. And so you can do that. And so all of this, you know, if you start putting all this together, you can make a really, can become a really powerful workflow. You know, for example, while I was preparing for this talk, I took my really ugly, you know, really slow Fibonacci algorithm that we talked about, and I ran it with durations 3 so that I could see, yeah, this is slow. And I had Pytest watch running so that anytime I hit save, it would immediately kick off. And then I can play around with different algorithms, and the durations output will tell me if I'm doing faster, and the test suite will tell me if I broke something. And so, you know, to have that kind of confidence as you're doing work that I've made don't break anything, and if I do accidentally break something, then my test suite will tell me. I mean, it's a really nice, you know, really powerful tool for a developer. Kind of getting into some more specific examples of Pytest features, and some of this comes out with what I've been working on at Windrock. You know, so far we've been focusing on unit tests, and that's kind of Pytest's. I mean, that's what Pytest is written for, but you can. It will work for any testing. And so I've been doing it at Windrock. We have a Windows C++ application that, for a variety of reasons, is a little bit hard to do automated tests of just purely within code. It's using Python PYWINAUTO to actually automate the GUI and operate it as if a user would, and verify the results. And then I've been using Pytest to kind of automate all of that and tell me if something's wrong. Falls with doing GUI automation. It's easy to write because, you know, if you change your UI layout, it may or may not continue to work. So this is still kind of in the experimental phase, but if nothing else, it's a really powerful Pytest can do. One of the features of Pytest is fixtures, they call it. So so the example here, you know, if you're using PYWINAUTO to do automation, the application, and then each individual test would need access to that application, and then you close it once you're done. And in a standard, in Python's built-in unit test module, the way you do this is your setup method and a teardown method where you do all of this. But Pytest is more flexible. Pytest uses fixtures, they call it. So here I register this Pytest fixture. I can do whatever setup I want within the fixture. If I wanted to, and then I'm using generator syntax to pass control over to whatever the actual test is. And then when I'm done, I go ahead and close it. And now I can write any tests and declare that it needs this fixture. And then Pytest, again, using when it runs this test, it'll say, oh, okay, well, I need the notepad fixture, so I want to go ahead and run this. And then pass the results in, and then PYWINAUTO will do whatever it wants. In this case, I'm making sure that the notepad clipboard works. And then when it's done, it passes control back to here and finishes. Pytest has some built-in fixtures too. You can check the documentation for details. For example, it provides a temperature fixture that if you have a unit test that needs a temporary directory to, you know, kind of as a scratch pad, you can pass TMPDIR as a parameter, and it'll automatically take care of that for you, and I think clean it up once you're done.
Gosh, the PYWINAUTO, is that part of the Pytest?
No, it's a separate code that I found where is working well together for my purposes. Yeah. You can use PDB as a Python debugger if you've ever used that. And the idea of PDB is anywhere within your code that you want, you import it and then call set trace, and then whenever that line of code is hit, it'll break and launch a Python prompt that you can mess around with. PDB++ or PDB-PP is a drop-in replacement for that. And so all of this works well with Pytest too. So you can drop a breakpoint in the middle of your test, Pytest will detect that and then go ahead and let you inspect things. Or if you want, you can pass -- PDB, and then whenever a test fails, Python will drop into the debugger there. And again, all of this and all of this can make for really fluid coding style. What I started doing with PYWINAUTO is I'd write my fixture and write the first half of my test and kick off the operation, and then trying to figure out the best way to automate, to manipulate the API to get the results I wanted. I'd just go ahead and drop a breakpoint and start playing with it interactively. Once I was happy with the results, I'd go ahead and save it into my test suite. And so all of this makes for a really fluid coding style. You write your code and kind of thing Python's really good at. You write some code and then you test it out, or you manipulate it in IPython to make sure it does what you want. You write some code and then you let Pytest watch execute it automatically and make sure it's still doing what you want. You run your code and then you use PDB to manipulate it, and so you can, mess with the innards of your program while it's running, or you manipulate it in IPython and then save it to a file, and you can run it whenever you want to then. So all these tools, really fit together to provide a lot of very fluid and powerful coding style, especially compared to, like I said, I do C++ for a lot of my day jobs, so it's save, build, wait 30 seconds, get bored and surf the web, Potentially. Pytest, you can, it has several command line arguments. So again, you'll want to check the website for details. But one common option is you can filter tests. If you know that you only have a few tests you want to run, you can pass it an individual file to run. You can pass it a file and then _ class name or function name if you only want to run that class. It has additional options, I think, to filter based on search expressions. I didn't write that down. That's really, that's kind of the extent of my experience or where I've gotten. One other can of worms, which you may come across if you read up more on this, is the idea of mocking. And so, for example, suppose you have a client for a web service and you want to write an automated test for that, you don't want to hit the website every time you run your test suite. And so you use a mock object, which pretends to be the actual HTTP client and always has, gives you the same results, so that your code that uses the results of that will think it's talking to a web server. I've only scratched the surface of that, and that's probably worth a separate talk by itself. If you're interested in more reading, here's some of the, I mentioned kind of some of the debate and discussion. Here's a variety of viewpoints on how unit tests ought to be structured, how automated testing ought to be done, and so on. I think you said you put talks up on the web afterward. Is that right? Yeah. So you can follow these links. It's good reading. It's thought provoking, even if you don't necessarily agree with all of it. If you're interested in books, I have not read these myself, but correction, I haven't read the first 3, but I've seen them consistently recommended. And then The Clean Coder by Robert Martin, Uncle Bob, again has 2 or 3 good chapters on testing and the testing and levels of testing and so on. Any questions or feedback?
Have you noticed much of a performance difference between Pytest and...
I have not seen any. One of the disadvantages of doing GUI automation is it's really slow. So I wouldn't notice any anyway. But I have done, like with the Django, there's a Pytest Django plugin, which I didn't link to, that basically just improves Pytest's ability to detect and run Django tests. And so I'll leave Pytest watch with that running, and it's plenty fast. Yeah.
Can you talk a little bit more about test discovery?
Yeah. So basically, it's just, how does Pytest find have, all your test cases, all your individual unit tests, potentially hundreds of these for a decent sized project. And so the question then is just how does the code find what it needs to? So when I've used unit test, and I could easily be doing something wrong, but what I was doing was tried to jump through several hoops in order to find all the functions or all the functions across all the different modules and run them. Whereas Pytest just has built into it that it's smart enough itself to search through the current directory to find files with the appropriate names and then run the appropriate tests.
Okay. So there's nothing else inside which is doing something besides what you said for the code showing probably covering 60-some% of that. There's nothing that it's doing that says, here's the place where you might think where you're probably missing some tests or something. That's not what code is doing.
Correct. Correct. Okay. Yeah, your coverage report, if you see 2%, that's a warning sign. But other than that, yeah. There you go. Look at the bright side.
It's 2% than you have.
Yeah, one of the debates online is, what code coverage number should we target? 80% or 90%? Because it gets really, really hard to cover every corner case and every except block and everything. And I kind of want to say the right answer is, 0.5% more than last week. As long as you're moving in the right direction, it's something. Any other questions or comments, or anyone have their own experience with automated testing? Mm-hmm. Off the top of my head, I don't know. I'm sure that people have looked. There's probably a Pytest plugin for it, honestly. So Django has. This gets back to I'm not an expert, and so I am kind of learning this as I go. Django does have support for. It has some helpers for tests, so I can do stuff like issue a request, and it'll make it work internally somehow, and then I can do stuff with the results. That's right, yeah.
So you can simulate the request response cycle without actually, like you said, having to have a web server.
So it'll have stuff. Django does have stuff built in that helps, and I'm sure Flask has something similar. Right. Yeah, that's a lot of what the book is kind of, if you have an app, here are strategies for modernizing code, breaking apart code. And because one obvious testing strategy for something like Flask or Django or anything is, well, even if this particular web request handler is hard to test, we break it apart so that the logic lives in separate functions that are more accessible. And that's often good. It's easier said than done, but that's often good software design in general. And the legacy code book will, has some techniques for that, suggestions for that.
Cyber attack that happens on a computer in your program. I say something's being considered in here and it's not correct.
Well, so the idea of Pytest is it runs your code, right? So if the attacker injected something into your source code, it would find it, but generally you're not trying to write tests against a running system or against a programs outside your code. I mean, there's no reason you couldn't, just like I'm using Pytest to automate a C++ program, but it's not really what it's targeted at, I guess.
I'm looking for a negative rather than a positive. So if it passes all the time, that's only a fail.
Yeah.
Something went wrong with the program that didn't happen 10 minutes earlier. So therefore, something modified the program.
Yeah, I mean, it could be used for that, but I wouldn't expect it to be a great fit. I would guess that most attacks would. I wouldn't place a great deal of confidence in my test suite catching that kind of attack. Yeah.
Somebody's got access. But I think, not to completely put it out like that, I think there are probably some better options out there that might exist.
If I wanted to seriously protect against that, there are programs that can encrypt themselves, right? So they decrypt themselves as they run. And if somebody does meddle the instructions in that program, the encryption fails and the program fails. But that, I think we're really kind of getting well away from testing.
If you just wanted to test to see if your source code files have changed, you could just use a diff. You know, on Linux command line, you could just run a diff against your code. Compare a known good version against what's there. It can tell you what's there.
Maybe test against your code.
And if it's my executable binaries, then you just install the checksums.
There you go.
Like that. That's okay. Well, it's not still.
Yes, it is.
Well, I just want to make a side comment in that I have existing unit tests, and when I came into this talk, I was a little skeptical because it's like, this Python, I don't have to install anything new. And the unit tests work, and they're pretty simple, straightforward. So if it ain't broke, don't fix it. But you know, now having sat through your talk, I'm at least willing to give Pytest a try and see. Okay, maybe there is a little bit of value added to Pytest. So I'm really go. And installing is
Yeah.
I think the simplicity also of compared to unit testing, when putting it together, it's much easier. So you can actually write your unit test quicker. Compared to what we have right now, going forward, I would definitely choose this over unit test.
Well, I'm definitely very curious about the ability to use mockups of some kind. So I work at RNL. One of the projects I'm on basically scrapes utility websites to get their outage information. And so most of the time there are no outages, and so it makes it difficult for us to test our scripts because unless we want to put together a special DOE SWAT team to knock over where the outages. Right. So, you know, it kind of puts us in a bind as far as testing our Python screen scraping scripts. So that would be nice. So what we were thinking about doing is that, finally, the utility has an outage, is to basically save the outage information off to the side, archive it. So that then there is possibly like some sort of unit test to test against that. So if we change the parser, we can just run it against the saved known outages to make sure that it's still reporting the outages properly. And I was thinking, well, that's going to be kind of a pain to put together, but gosh, it would be nice if I could, as unobtrusively as possible, modify the existing scraper scripts. Or maybe even in a unit test, where normally when I call request to get something from a URL for a website, that instead it sneaks around behind my back and basically pulls in the archive values
Yeah.
I'm not sure it can exactly do that, but it can.
My understanding is that the mocking libraries would make that pretty easy. I just haven't tried it in Python.
I would be surprised if you couldn't do that. I mean, that's kind of a common.
Yeah.
Yeah, I think Rails really has some kind of facility for that. I mean, Google did it, that's a home bot for all the AWS APIs. So truly,
Yeah.
website.
Thank you for that.